Oh, look at this. This is cool. Hey everybody, Jason here. I hope you're all doing really good. Today, we're working on an iPhone 7 Plus that was sent here for no backlight. This, to me, strikes me as a little bit peculiar because the iPhone 7 Plus, like most iPhone Plus models, have two independently functioning backlight circuits. So to have absolutely no backlight, that's a mystery. So we're going to have a look at this thing, we're going to see what's going on, and I'm going to see if I can fix it. So here we are under the microscope. This device, like many devices that are sent here, looks to have some little bit of probe action going on here, right? Huh? You see what I'm talking about? The caps here have these little scratch marks on them where they have been probed and sort of poked around on. Somebody, I think, may have had a look at this one and decided it was going to be tricky. And that one went into the pile to send to Jason. How about that, right? All right, well, let's not do anything to this. Let's start. We're going to start all the way out here at the connector. On the iPhone 7 Plus, these pins down here toward our bottom right on the connector, these pins are our backlight pins. Now, to show you what I mean by that, let's switch over here to Flex Board View. And we're going to zoom in on the connector. By the way, thank you, Paul Daniels, for Flex Board View. Paul has a YouTube channel and also posts routinely whenever conditions are right and everything is good. If you enjoy this type of thing, I do encourage you to look at Paul's channel. Let's zoom in and look at this connector. You can see the first pin in line here, PP-LCM, backlight 34 cathode. So this is a cathode. The next one over, this is one of our anodes. The next one over, we have another cathode, cathode, anode, cathode, cathode. So basically, let's just check them and see what's up, all right? We're looking for high or low readings. We're going to check this in diode mode reading. I'll pull out my probes here. They're kind of buried in the drawer. Everybody look out. Jason's going to pull out his probe. We're going to set the meter to diode mode. I will be putting my red probe on ground, and I'm going to be pecking around with my black probe. So, starting from our bottom right, we're going to be checking this one. We're getting a 0.5. That is acceptable. Our next one, we're getting a 0.4. That is acceptable. 0.5. 0.5. The next one was anode, right? So it should be 0.4. Huh. What's up with this phone? Is it really no backlight? Is this phone like really no backlight? I mean, that's our main guts there for backlight and everything tested good. Let me grab a test screen here. Oh, the test screen. We're going to connect that sucker right up right here. And let's get us a probe hooked up. That'll work. Settle down now. Okay, we've got the power supply off. It is set at 4 volts, and it is configured to be able to deliver up to 3.2 amps. Hopefully it doesn't consume anything like that. All right, so now we've got the power supply hooked up. We're going to press the button to turn it on. 0 amps, that's good. And we're going to prompt it to boot in 1, 2, 3, boot. 800 milliamps, 160. The phone is booting. Why is this here? Seriously? Backlight, right? Serenity now. Serenity now. How long has this been here? Let's see, this showed up on the 2nd. We're still within our given turnaround time, but man, that sucks. Okay. That is turnaround time on routine repairs. We're not talking turnaround time on prior repair attempts. That is different. All right, so we're drawing a 1/2 amp of current. It's taking its time booting. That's normal. And we're up to a lock screen. Not only do we have backlight. Oh, wait a minute. I don't have working touch. No. Rebooted, right? 1/2 amp. What happened on this one, guys? It might have blank screen. You know what? Let me just slip it into a housing, make this easy. Turn the power supply off. I will grab my iPhone 7 test housing. I'm going to stick it right on in there. All of this just so I can have a button, you know. So let's hook up the button, hook up the screen, hook up power. I might as well, should I put it on a DC power supply? Yeah, let's continue to run it on the power supply. There we go. And we're going to press the button to boot this time. And 1, 2, 3, boot. I think it's fine. Now I'm wondering, this came in as board only. All right, so let's let this boot. This came in as board only. And I'm wondering if maybe it went to the shop for a screen replacement and they had a connector. No? No, because the style of connector that's on here, it has a way of getting pins that are sort of pushed back inside the plastic. So it's easy to have it's actually really easy to have a connector problem when the connector looks perfectly fine. It just needs the pins tensioned a little bit. So I started to think that maybe this was a connector issue, but if it was connector, again, we would only be missing partial backlight. We wouldn't just lose both anodes and have blacked out blank no backlight unless it was the one, like a pin that would cause us to get no image. That could have been. This may have been a no image phone. Let's see, so it finished booting. The screen went blank. We're still drawing a 1/2 amp of current. And after the screen went blank, now I see it. There we go. So this phone is actually getting no image. I don't know if you'll be able to see that or not. See when I push the button, the screen gets lighter and darker, lighter and darker. You probably won't be able to see that, but I can see that on this end. So this is not a no backlight phone. This is a phone that is losing image. Processor. This is going to be a problem with the application processor. Oh, serenity now. All right, so it boots and then loses image. Let's see that once more. We're going to press the button to have it boot up. And also, let's see, do I have another test screen immediately handy? Let's see. All right. So here we have another iPhone 7 Plus test screen. This is one of the, this screen here, let's not hook up the home button. This screen here, this is one of the better test screens in the shop. This one here, it's practically perfect. There we go. Let's hook up our power supply. I'll be surprised if this one even works. All right. And we will press the there we go. And let's press the button to boot. This is really a bad screen to test with, but at least it gets an image. Okay, so that's all I'm really concerned about. I want to see if this thing boots up, if it gets an image, and then it loses an image. Come on, baby. It's already fading, isn't it? Oh boy, look at that Apple logo fade out. It just sort of like fades into nothingness, right? And now we've got vertical lines on the screen. We didn't get that on the other screen. Oh, look at this. This is cool. So amazing. A new problem. Well, sort of amazing. I would like for it to be a known problem where I can just fix it real quick. So this is not, guys, this isn't a backlight problem at all. This is an image problem. And man, the way that it's behaving, that's like, geez, that's like really, really weird. So I'm going to get in. First thing I'm going to do, I'm going to start checking image power lines. The way this thing sort of like faded out, I've not seen this symptom before, so I really don't know what this is. I'm going to start checking some image power lines here and see if we can figure it out. Now, for the most part, our image power, it begins somewhere up here around the center of the connector when PP1V8 LCM con comes in. But we've also, like we talked about, we've got some backlight stuff going on down here, and then we've also got some power related stuff here. So I'm going to buzz around here and just start checking the total holy crap out of this thing. Now on the iPhone 7 or 7 Plus, I don't remember which one, I have ran into CPU level issues with these image data pins along here. So I'm going to kind of start there and check and see what we get. We're going to be checking in diode mode, red probe on ground, black probe on our measurement. Okay, so here we go. Let's just buzz along the top here. 0.4, 0.4. Each pair of two will be separated by a ground. Okay, so then we got two more data lines, 0.4, 0.4, ground. Okay, 0.4, 0.4, ground. Last set. Going to be 0.4, 0.4, ground. There we go. I'm pretty sure that's our last of that pattern. Yes, 0.4. So there is our last ground on that set of stuff. Now switching back over here to have a look at board view, you'll see that what we've done here is we just checked out here at the end. We've only checked this row of image data lines, and we ended on this final ground. So just after that final ground, we've got this LCM to Manny B-Sync, Chestnut, Power Enable. We do need to worry about this. We absolutely need to be worried about the 5V7, the reverse bias line here. We need to be worried about 1V8 LCM Con. Honestly, a lot of these we need to be worried about, but we're going after main guts and glory here, guys. We're going after the power. So let's go ahead, let's have a look back under the microscope. And I'm going to go ahead, I'm going to pin around here and peck around and see if I can find anything out of whack. All right. So I can use our final ground there as like a place to remember where I was at. So here we are again, red probe on ground. Wait, where's my meter? Come on, baby. There we go. So here we are again, red probe on ground and black probe to find ground out here. 0, that's our last one. So the next one over, we decided that was our, our mini line. Next one is Chestnut Power Enable. It is good. The next one over is our AV DDH line. It is good. Wait, is that not the reverse one? Okay. Next one over. That is Power Enable. I'm a little bit lost. Let's, I got sidetracked here. All right, so there we are at our ground. This reading's good. This reading's good. 2 over from the ground to the right. We're getting a 0.7. And is that right for that one? I don't feel like 0.7 is too out of whack. Let's reverse it and let's see what we get there. Okay, so that's our 0.7. Now I'm going to test that same one with our red probe and then black probe on ground. It's 0.9. That one's making me feel a little uneasy. What should we get on that one? 1, 2, 3, 4, 5, 6, 7. That is 8 over. And what is this, a 7 plus? Let me just grab a, do I have a 7 plus here that doesn't have the processor ripped off of it yet? Probably not. here is an iPhone 7 Plus that has seen better days, but I should be able to get a reading off of that pen at least. What did we decide? It was 8 over, so we were getting a 0.7 on our customer's board. So we're going to do red probe on ground again. We're going to check the 8th pin over on the right-hand row here. 3, 4, 5, 6, 7, 8. 0.7, it is good. We don't have to worry about that one. So let's get back in here, let's get back to our customer's board. We're not worried about that pin. That is a good reading. This is a really strange one, right? So that's just what we get on that pin. Okay, so we're at a 0.4, 0. That's our ground there, right? That is right. So we got 5 more pins on that top row. 1, 2, 5. We're okay with those 2 readings. All right, back down here to the bottom right. Remember, we already did all these backlight lines. It was cathode, cathode, anode, cathode, cathode, anode, and then, or something like that. It's the proper amount of pins. And then we had ground. There's our ground. There's our clock line. Clock line, those are both good. We're not going to worry about this one. We're not going to worry about the Manny. We're not going to worry about this AVDDH. It looks good. Yep, that's our reversed one. So reverse polarity and we get that one. 4.8. 4.2. 4.1. These are all coming out good. 1.7. Wait, 1.7 on an I2C line? I don't think so. Try that again. Red probe on ground. Let's check that I2C line again. We're getting a 1.7 on that. Can that be right? That seems really high. How about the data? That's the clock line. Let's check the data line next to it. Yeah, see, that's more like it. Let's take our other board and check that line. Remember, we've got another board laying right here that I assume used to get image before it was screwed with. Let's put our red probe on ground. This is a so-called known test board, and we're going to check and see what we get on that line. 1, 2, 3 over. I don't think we should get no 1 point. Nope, we get 1.7. I'm off on the wrong track. Let's not do any digging. All right, so our I2C lines are getting the right readings. I'm getting the readings that I would expect to see on our power lines. I know I kind of got fumbled around there for a minute, but I still didn't find anything that was too high or too low. Why does this thing have a fading image? Aftermarket screen, we had a fading image. An OEM screen, we had the Apple logo faded, but then it went into like all this gnarly crap. What the heck's going on with this? Let's peel the sticker off and look at the bottom of the board. I'm tempted just to throw another chestnut IC on it. Let's have a bit. This has been peeled back before. I might have done that whenever it first came in. All right, so here we are looking at the bottom of the board, and this all looks, I mean, looks fine. We don't have any prior screwery. I mean, nothing. Somebody looked at it and decided, wait a minute, this isn't a simple backlight problem, and they sent it to me. But everything looks good. Has it been slammed? Like, has the phone been hit real hard? Wait a minute. Balls popping out all along the Wi-Fi IC. Is that just coincidence? even back here, balls popping out. All right. Evidence. Let's go ahead and get under the other sticker now that we have balls popping out. Are they factory balls? Or do we have some really sneaky prior rework going on here? Huh. No? It appears to be only the Wi-Fi IC area. So this was probably just like a manufacturing glitch, like it sat too long in one machine or something. Let's not worry about that too much. So this sucker just sort of like bombs out. Let's read the ticket. Pretty sure it's just a backlight repair, supposedly with strong air quotes there. Best Buy said that they replaced the backlight already and that they didn't resolve it, but I know they don't know how to do anything like that in store and blah 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 yada yada yada. Look at it yourself. Yeah, okay, got it. So may or may not be a backlight problem, not a backlight problem, but so they weren't really sure. Back to this repair. Let's hook up to this with an iBridge, all right? Let's see what the power's doing. iPhone 7, 5.5. Here we are. Here is our iBridge. This is a wonderful product from Qian Li. I turn to these whenever times get rough. What this does is basically we're going to feed the display signal through this. We're going to hook one side of it up to the logic board, right here. There we go. And then we're going to hook the other side of that up to our display. You know what? That reverses it. I think we have to turn the display around the other way. Crazy. There we go. So now we have our display feeding through this conglomerate of a thing, which allows me to take measurements while the display is connected. Because if you don't have a display connected, then you get no display. I mean, you don't get image power. It doesn't light up the power lines unless you actually have a display hooked up. So it's important to have the display hooked up. Now let's go ahead and test fire our little gizmo here. And we're going to press the button to boot. Oh, there it is. Okay, we're going to press the button to boot and see to make sure we still get an image. So here we go. No image, right? We did have an image, but now I have no image. Interesting. Let's try our other screen. Without the home button. I don't like the way the home button looks on our iBridge thing. Okay, so, oops. So here we are. I've got a different screen hooked to it now. We're going to press the boot button. 1, 2, 3, boot. Image. Huh. That's peculiar. All right, we're going to get ready with a voltmeter here. While this boots, we've got image on the screen. I'm going to switch you over to the microscope. I still have an Apple logo on the screen. I'm placing my black probe on ground. And I'm most curious about our 5v7 line here. I'm getting 5.7 volts. You can see that on the screen. The image is fading. Fading, 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 fading. The image is completely gone. I have no more image on the screen, and I'm still pulling 5.7 volts from the image power here. All right, 1v8 is good. 5v1, good. 1v8, good. 5v7, minus 5v7, good. 5V7, good. So we've got our plus and minus 5V7 there, good. Over here we've got a 6-volt line. 15.7, what did I... No, that's 25 volt. Okay, so that's backlight lit up nice and bright at 15 volts. And that's right, I'm confused. I don't actually have a 6-volt line out here. That's another part of the circuit. So we can safely assume here by looking at this that Chestnut is online and happy. This thing is working. What else do we have here? Starts up, but then image fades. There's really no reason to change the 1.8 volt filter, which is crammed over here somewhere, because 1.8 stays up. All of the Chestnut image power stuff stays up. Okay, well, there you have it. This board boots up. It has working image. It boots with working image, but then image fades. It has working backlight. Backlight does not fade. The backlight voltage stays up high. I have verified that Chestnut appears to be up, online, and happy. It is providing power. I guess we could try to replace Chestnut in this case. I mean, replacing Chestnut could fix it, but Chestnut is responsible for providing these power lines and these 5V7 lines, plus and minus, 5V1. These lines, they're getting voltage from Chestnut. The backlight lines that was putting out, what, 15 volts or whatever, those lines are actually being produced by the individual backlight driver circuits. So all things image power look good, yet we get a fading image. I feel like this is going to be GPU related. I'm not sure if there's anything outside of the GPU that I will be able to touch and put my hands on to actually be able to fix it. But this one here is a little bit of a mystery. I feel like there's going to be a fix like right here by it. So in this case, I am going to go ahead and leave this up to you guys. If somebody out there in my audience understands what is wrong with this board, feel free to leave it in the comments below. I would love to hear it, and I'm sure the customer would be glad as well. So that's it for this video. If I get this thing up and running, I'll post a solution. Thank you.